Hi everyone, today we are looking at a question like this. Now, this is a volume question and it is a very typical PSLE question. Okay, so make sure you watch the whole video. Now, as you can see over here, it says that P and Q are two rectangular containers. So we have P on the left, Q on the right. At first, container P contained water to the height of 18.5 cm. So this is the height of water. And container Q was only 2 cm. So, well, this is shown in the diagram, right? Now over here, they say that the volume of water in container P was 1,480. So what you want to do is quickly write down, okay, that the volume for P, all right, is actually equals to 1,480 centimeter cube. And because you have the height over here, you have the volume, you can quickly find the base area of container P, which is what they want us to find in A. So we are just going to write base area is equals to volume over height. So this is basically 1,480 over 18.5. Okay, so when you do that, you will get to an answer of 80 centimeters square. So therefore, over here, it's 80 centimeters square. Now, well, before you move on to Q, right, what you want to do is learn how to also find the volume of Q. Okay, so the volume of Q, as you can see over here, is 40 times 9, which is the base area, times the height. So over here is 720 centimeter cube. Okay, now very important. Now then we move on to the next one, right? This person decided to pour some water from container P into Q. All right, so I'm just going to zoom out so that you can see both. All right, without spilling. And after that, the height of the water level of P was the same as that of container Q. So when the height of the water level, okay, the height of the water level in both of the containers are the same, then this is where you will have to do it in this manner. So what I'm going to do is I'm going to write down that the volume of P, okay, is at first 1480, okay, and the volume of Q, all right, is actually equals to 720. So what happens is that P is giving some water to Q, right? Now, then what happens is this, right? Is that some water came out. So some water came out. So we don't know what is the volume of P. All right. We also don't know what is the volume of Q. Okay, but what we know for sure is that the height of P is the same as the height of Q. So maybe we will just put height as H first because we don't know what is it. This height can be 10, can be 20, can be 30, can be 50. We don't know. Can be 5, right? So all we want to do is just write height first. Now, but there's one thing that doesn't change in container P, and that is the base area. No matter how much you pour or how much you take out, the base area will never ever change. You must always remember this, okay? So this is 80. And for this itself, right, for Q, the base area will also never change. And we can see over here that the base area is actually equals to 40 times 9, which is equals to 360 centimeters square. So what we want to do is we want to also write down 360. Now, there's one thing you know, right? And that is to find the volume, I will just have to put 80H over here because the volume is basically the base area times H, right? H, we don't know, all right? So maybe let me just be more specific. I'm just going to write 80 times H, which is equals to 80H. And for the volume of Q, it will then be 360 times H, and that gives me 360H. Now, we know that the height of the water level is the same. So we use H to represent, and they want us to find the new height of the water level in container Q. Now, do you remember just now, right, in the earlier part, I say that the volume of P is 1480. So isn't it true that 1480 is actually equals to 80H? Okay, I'm just going to highlight for you to see, isn't this the volume of P? And this is also the volume of P. So what happens now, right, is that you can see that the volume of P before and the volume of P after is definitely not the same because I've taken out something from here, all right, and put it into Q. All right, so the volume of Q before is also not the same as the volume of Q after, but there's one thing that is the same. Do you remember this concept called internal transfer? All right, now if you were to look at this, right, you realize all we are doing is just pouring water into Q, but the total volume never changes. So this is a concept under constant total. So what we want to do is to write down that our total for before is actually 1,480 plus 720, and that gives me 2,200. Now, for the total for after is also the same. However, I do not have the exact amount because I do not know what is the height, right? But you can be rest assured because the total doesn't change. So we can say that 440H is actually equals to 2,200. And we want to quickly find H, all right? So all we need to do is just 2,200 divided by 440. Okay, when I do 2,200 divided by 440, we get to an answer of 5 cm. So what exactly is this 5 cm? This 5 cm is the height of water level in P and water level in Q. So this H over here is actually 5 cm, and then this H over here is also equals to 5 cm. So therefore, the answer says, what was the new height of water level in container Q? Your answer has to be 5 centimeters. Everyone, today we are looking at another question about volume, and this is from Maris Stella. Now, as you can see over here, it says that X is a cubical tank of size 20 cm. So because of that, you want to quickly note down, all right, all of these things. Okay, first thing first, of course, you can say that the capacity, all right, the capacity of X is actually equals to 20 times 20 times 20, all right, and that gives me 8,000 centimeter cube. Okay, then the next thing you want to write down is the base area of X. The base area of X will then be 400 centimeter square. Okay, so once this is done, right? Once this is done, we can also go to Y, and you can see that the base area of Y, okay, so the base area of Y will then be 60 times 20. All right, so we have 1,200 centimeters square. Now, what happens is this, right? Is that the person poured some water from X into Y without spilling. After pouring, the heights of the water level of X and Y were the same. Okay, this is a very, very typical volume question that they like to test, because students are not able to understand, how is the height of the water level the same? Okay, so what I want to tell you first is this, right? Whenever they say, all right, or whenever they ask for height, you must always remember it's volume over base area. And if the height is the same, then it will be what we call combined base area. Okay, so this C over here means combined base area. Okay, combined base area. Okay, so what we want to do first is, of course, write down whatever we know. Okay, for X itself, right, it has a volume, which is also the capacity of 8,000. Okay, and it has a base area of 400. Okay, and then after that, so this is my before. All right, this is what happened before. Okay, and then for Y itself, it has a volume of which we don't know, right? In fact, they said that the volume of Y is empty, so we don't even need to write anything over here. For the base area, we know, right? For the base area, it is 1,200. Okay, so what happened was there was some pouring from X into Y, so that is my after. Okay, so that is my after. Okay, so what happens is that the base area doesn't change. You must understand that the base area never changes. Okay, all right, so the base area of this will still be 1,200. The good news is that the height, okay, is the same. So if the height is the same, we are just going to call it H. Okay, we are just going to call it H, okay, to show that height is the same. Or, well, some of you prefer to call it 1 unit. I think that works as well. Okay, so because of this, you know that the volume over here will then be 400 H, and the volume over here will also be 1,200 H, okay? Why 1,200? Because 1,000 times H. Now, you remember just now, right? If you have watched the first part of this video, all right, you will see that I mentioned something called internal transfer. So what exactly is internal transfer, and why is this internal transfer? Internal transfer talks about how, two subjects, okay, transferring amounts of item, okay, to each other, and that the total doesn't change. So because of constant total, we can say, or because of internal transfer, we can say that this is constant total. So let's ask ourselves, okay, what is the total over here? The total over here, total volume, it's actually still 8,000. All right, then wouldn't you agree that the total volume over here in my after is still 8,000? Why? Because the water is just poured from X to Y. The water is not poured from X and maybe to another tank. You get what I'm trying to say? So it is transfer in between. That's why we say internal transfer. Internal transfer means I am transferring from X to Y, Y to X, X to Y. But in this situation, it's only X to Y. Okay? But the total still remains the same. So what we can say is that the volume of X plus the volume of Y is actually still equals to 8,000. So 400 H plus 1,200 H is actually equals to 8,000. So when we have this, right, over here, we get 1,600 H is equals to 8,000. So what we want to do next is we want to find H, and H will then be 8,000 divided by 1,600, all right? And therefore, my answer for this question has to be 5 centimeters. Now, the question says, what's the final height of the water level in both tanks? Your answer has to be 5 cm. Hi everyone, today we are looking at a question like this. Now, as you can see over here, it says that container X and Y are rectangular containers. So this is X, this is Y, and the base area of container X is 30 cm. So we want to quickly write down that the base area is 30 centimeters square. And because of that, we know that the volume will then be 30 times 120. That gives me 3,600 centimeter cube. Okay, so this is for X. Now for Y, it says that the base area is 100. So what we want to do is we want to write down that 100 is the base area, okay? And we do not know the height, all right? Because, in fact, I would say we do not know the water level because container Y is empty. But for container X, you know, it has a height of 120. Now the question says, hey, I want you to find the volume of water in container X. We know that that is basically just 3,600. Now, centimeter cube. Now, so the next thing that we want to do is to read the next part. It says, John then poured some water from X into Y without spilling. So when I see something like this, right, I know that X goes into Y. It is once again an internal transfer question. Okay, now why is it internal transfer? Because I'm transferring water from here into Y. I'm not transferring out. I'm transferring water from here into Y. I am not transferring out. So what we want to do is, of course, to find out what is the before, okay, and definitely there is some transfer there, so there is an after. So we talk about X first, okay? You must understand that regardless of what you do to the tank, the base area doesn't change. Of course, unless you were to break it into half or you smash it, then definitely, right? But I'm just saying, if the amount of water that you put inside into each of the container does not change the base area, okay? So then therefore, we will make sure that the base area stays the same. For Y itself, same thing, all right? We know that the base area of Y is actually equals to 100 centimeter square, and the base area over here is also equals to 100 centimeter square. All right, now before that, right, before that for X, it has a height of 120. Okay, so therefore we know our volume, as we have found in part A, it is basically 3,600 centimeter cube. So we first obviously have to write down the total as well. The total volume over here is 3,600. Okay, and the total volume over here will also still be 3,600 because I am just basically putting some water, taking water out from X and putting it into Y. The total doesn't change. Okay, the good news is this, right, is that the height, okay, the height of X is twice. Is because it is twice, we are just going to put 2 units, and the height of Y is 1 unit, right? Why is it 1 unit? Because if X is 2 units, then the hidden information, right, has to be 1 unit. Okay, so what I have over here is my volume. All right, I do not know my exact volume. Okay, but I know that it is 60 units, and for the volume over here, it is 100 unit. Okay, so what you can see over here is this, right? Is that when I add the volume up together, I'll get to the total. So what is that going to be? I'm just going to simply do 60 units plus 100 units. Okay, that gives me 160 units. And 160 units, okay, is actually equals to 3,600. Okay, 3,600. We are going to find 1 unit first. So we do 3,600 divided by 160, and we'll get to an answer of 22.5 cm. So what exactly is 1 unit? This is 1 unit. All right, now the question says, how much water did John pour into container Y? So you can see Y is over here. So the amount of water, so volume of water in Y will then have to be 22.5, which is the height times the base area, which is 100. You move 1, 2, you get to 2250 centimeter cube. So therefore, this is my answer for this question. Hi everyone, today we are looking at a question like this. Now, as you can see over here, it says that the diagram shows 2 tanks, X and Y, okay, of different dimensions, and X was empty, all right? So we can say that this is empty, and for Y, it has 25.2 liters of water. Since we are dealing with cm, we're going to change this to 25,200 centimeter cube, okay? Now, Once this is done, you want to quickly write out your base area for this, which is 60 times 20. That gives you 1,200. All right, the base area for this is simply just 15 times 30. That gives you 450 centimeters square. This is a small centimeter square. Now the question wants us to find height, right? Remember, whenever you want to find height, it's volume over base area. Okay, if it is the same height, then you do volume divided by combined base area. Now they want us to find height for tab Y. So we just have to do 25,200 divided by the base area, which is 450. When I do 25,200 divided by 450, I will get to an answer of 56 centimeters. Okay, so this is actually 56 cm, so 1 mark in my pocket. Okay, now what happens is this, is that at 9 a.m. water from tank tab X flowed in at a rate of 7.2 liters per minute. So what happens is this, right? That for tab X, because it's, for tank X, because it is empty, so what happens is that water is going in. So we are just going to write for X itself, every 1 minute, okay, it will give or receive 7.2 liters, which is also 7,200 centimeter cube. All right, whereas for Y itself, for Y, every 1 minute, okay, it will receive 3.6 liters, which is equals to 3,600 centimeter cube. Okay, so these are some of the things that you want to write down first. Now, what happens is this, right, is that both taps were turned off when the height of the water level of X was the same as that of Y. Okay, so this is very important. All right, so since you know that 1 minute it will receive 7,200, so I'm just going to put plus over here. For Y it's minus, right, because they say flow out. Okay, because Y, it has something already, right? So what happens is that Y has to decrease, X has to increase, and when Y decreases, X increases, they will meet at a point. Okay, they will meet at a point whereby the height is the same. Okay, now so what you want to do is this. Okay, you have to find, okay, the height that increases every 1 minute. Okay, so for this itself, since you are finding the height, we'll just have to do 7,200 divided by the base area of X, which is 1,200. Okay, so we know for X itself, right, it will increase 6 centimeters every minute plus 6, every minute plus 6. For Y, same thing, height that decreases every 1 minute. Okay, all right, so we will just have to do 3,600 divided by the base area, which is 450, and we get to 8 centimeters. Okay, so this is the height that will decrease every minute for Y. Now, so the question says, right, at what time will the taps turn off? Okay, so what you want to do is this, right, is that you can draw a table. Okay, I have no space, so I'm just going to draw below. All right, so let's start with X, okay, and then let's go with Y. So we start off with, of course, 0 for X, and then for Y, it is at 56. Okay, for Y itself, we always have to minus how much? Minus 8. For X itself, we always have to plus how much? Plus 6. So the first minute, so this is at 9:01 a.m. because they started at 9 a.m., right? So 1 minute later, that will be 6 cm. Okay, so this is the height, not the volume. For Y, it will be 56 minus 8. That gives me 48. Okay, then at 9:02, what happens is that we are going to plus again, we get to 12 over here. All right, 48 minus 8, we get to 40. Okay, so you can see that we are getting very close. Now for 9:03, at 9:03, what happens? You plus again, you get 18. You plus again and you get 18. So basically over here, you just have to list down the multiples of 6 for X itself. Okay, 9:04, 24. All right, 9:05. 30, so on and so forth, right? Now for Y itself, we'll simply have to do 40 minus 8, that gives me 32, and then continue to minus 8, we get to 24. Well, you can see at the 9:04 mark, what happens is that the height of both tanks are the same. Okay, then if you want to just continue to double confirm, you can see that, all right, at 9:05 a.m., what happens is that Y will now only have 16 cm as the height. Okay, so therefore your answer, right, the question says, at what time will the taps turn off? Your answer has to be 9:04 a.m.